use 5 classes for this one. Now, I like to make this as physically, make as much physical sense as possible, because this is a beautiful physical idea we're about to use. The range is 29. It goes from 17 up to 46. So pretend like this is the 17 marker, and then it's 18, 19, 20, and then over here, over here is the 46. You guys with me? So there's like a giant ruler down here, and that's at the 17 mark, and that's at the 46 mark. You guys with me? And what I want to do is I want to cover, for some reason, I missed the 70s. I want to cover this whole wall with wood paneling. You with me? You guys okay? All right. And I want each of the panels to be the same width. Cool. If I use 5 panels, how wide would each panel have to be? That's a physical problem. It's not a statistics problem. Just, if I'm going from 17 to 46, so how far do I have to go? 29. Right? Yes. So maybe this is, I don't know, this doesn't look quite 30 feet, but 29 feet, let's say. And I'm going to use 5 wood panels. I want them the same width.
You just round it right to 30 and then divide by 5.
Not really, but we will round in a minute. But you're right, you divide, right? 29 total feet to go, divided by 5 classes or 5 panels will tell me how much each panel gets.
So you don't care if it's like a whole number?
We're going to make it a whole number, but yeah, physical reality kind of runs out on me at the end because it doesn't fit perfectly here, right? But what we're really doing is there anybody that might have been 80 in this? 80 weeks. Could anybody have had 80? Yes, but do they have to have been in 80? No. But we can't just suddenly stop at 72 because it's the highest. I'd have to have these be the same width. Or else I might be trying to be sneaky. Okay, maybe. Yes?
So you're using range to divide.
So how do I find what's called the class width? Is the range divided by the number of classes. That tells me how much of that goes in each of these. How much does each of those get, right? If I had $29 and there's 5 of us, well, how much money does each of us get? I divide 29 by 5. So there's 29 total range, and I got 5 panels. Well, how much does each panel get? 29 divided by 5. And what is 29 divided by 5? 5 point. The quick way to divide by 5 is multiply by 2. And then move the decimal back, because that'd be divided by 10? Yeah, so 5.8. Or some of you guys are like, no, the quick way, Jeff, is this. All right, so. And then we always round up if we need to. We round up. If I round down, I'm not going to cover the whole thing. I want to over cover, if anything. I want a place for every data point to go. If I ever round, so if this was 5.2, what would I round to? 6. So I'm not just rounding, I'm always rounding up. I want you to really get this. If I round down, am I going to cover the whole thing? No, every panel is going to be a little shorter than it's supposed to be. They're not going to cover the whole thing. Can I over cover it? Yes. So you round up. How we doing? Now I am going to show you two different ways to do this. One of them is the book way. I'm going to do that first. And then I'm going to show you the way that I was taught. And I don't care which way you do it. You do it whichever way makes more sense. I am sort of going to be pushing you in one direction because one way sucks. But we'll see what you guys think. I'm not going to think less of you if you use the way that I think sucks. You're fine. Let me see, what can I get rid of? All right, so we know the width is 6. I'm going to write that up here. How wide each class is going to be. So what was the width there? 10. on your paper, we're going to have like several things here. So you don't have to, but you normally start at the first data point. And the first data point was 17. Now, the book method is funky. So just, you gotta understand, this is gonna be a little counterintuitive, but then I'll show you my way, and we'll see which way you like better. It's not really my way, it's the way I was taught. If the classes are, I should have written this down. The width was what again? 6? If the classes are 6 apart, where should the next class start?
23.
23. Is everybody cool with that? There's no question, right? If I put 23 here also, then where do the 23-year-olds go? Do they go in the first class or the second class? Do they go in both? Do I count them twice? Just because Jim Carrey had a problem with that number? Does anybody get that reference? No? It's called 23, or the number 23, right?
Just 23.
23? Yeah. Anyway. Creative title. Anyway. Sorry. Go off on a lot of tangents. So I can't, if I put that down, see why that doesn't make any freaking sense. Where does the 23, where's the 18-year-olds go? In the first one. Where's the 24-year-olds go? Second one. Where's the 23-year-olds go? Whichever one I want? No. So too bad for you. You make this go down one. Yes?
So for this example, you left it for 10 to 20 and 20 to 30.
No. I'll explain to you. When I show you my way of doing this, you'll see. If you do it the book method, you've got some extra shit to take care of. But you'll see. Well, anyway, you'll see. Yes?
So would that mean the next one's 23 to 28?
So what I normally do is I start, what's the width again? 6, right? Yes, Jeff, there it is. 6, 6, 6. You guys with me? And then I come over here and go 6. See how it's one less? 6, 6, 6. And what did I end up at? Me. You're not always. Be careful. I want to be with. This number just has to be at least as big as the biggest data point. It could have been 50, and it doesn't mean I did something wrong necessarily. Are you guys with me? You don't have to end at the highest data point. Because what if I was 45? What if I was doing this a year ago with you guys? We would have all been a year younger, but oh, just go. It would have still ended at 46, wouldn't it? Where would I have gone? Here. Where do I go? Still here. Okay. Yes. Now, this is the frequency, which I affectionately refer to as the freak. What do you think? What's your gut tell you I do to figure that out for this class? The frequency is how frequently somebody had the age between these two. So how frequently did that happen? Did you already tell me 25? I just didn't trust you. You guys with me? That's all the frequency is. That's why we call it the frequency. What's the frequency? It's how often a data point showed up, how frequently it showed up in that class. And now you see why we have to kind of like go down one here so that 23 has a definite home, right? Okay, maybe. So I can't see the width here. I can see the width here.
So where did you get the feedback from? Is it the amount of students?
Yes, how many students? How frequently did a student show up with an age between these two? 25 times.
Okay.
Yeah, that's why we call it the frequency. I love it. So what about 23 to 28?
4.
Yeah, there's only, 4. I like it. 29 to 34. 1. Is everybody seeing this? Everybody with me? You guys seeing this? 35 to 42. And then 41 to 46. 2. And then I didn't count how many total, but we should have 34, right? Well, this will work out good later. So it's 33 of you guys. Because I'm going to put you in groups of 3 later. Yay, group work. Love it. Now this, humans have improved on this. I want to get a feel. This doesn't really tell me. I know most of them are here, but there's a better number that tells me relative to everybody how many are here. So that's why it's called relative frequency, but we know it more affectionately as percent. So when you see relative frequency, all they really mean is percent. So what percent of the students are in this class? How many students are in this class? 25. Out of how many people? 34. That is a percentage. 25 out of 34 is, I don't know, 60.6. No? What is it? 0.73? Yikes. Well, we're going to do this by hand. So we're going to say 73.5, you said? Because the next number's a 2, right? Yeah, these we're going to draw by hand. So I'm okay with going like 1 decimal place. Yeah. Good point. You could go 4, but when you graph it, you're just going to estimate where it is anyway. So what about this guy? It's going to be 4 out of 34. Oh, I see what I was trying to end. So that's roughly 12%. So it's going to be like 11 point something. 11.7? Is everybody with me? Everybody with me? You guys all right? Okay. And then 1 out of 34 is like 3%. It's going to be 2 out of 34. Who is it? 5.8? Okay, that makes sense. And then 2 out of 34 is still 5.8. These should all add up to be 100 or close. We did round, right? So it should be really close to 100%. If you get like 95%, you left people out. If you get 104%, you created people, right? You really figure them out. So I don't know what the hell that adds up to be. What's it add to be? 11. 93.4. What is it? 23. Yeah, I get 99.8, but I did it in my head, so maybe 207 looks right. Yeah. Okay. How you guys doing? There is one more thing that the homework is going to ask you for that I'm not going to make a big deal out of, but you still better freaking do in the homework. And that's something called cumulative frequency. Just so you know it exists. And that does exactly what I hope some of you guys might think it does, which is how much have you accumulated as you go down. So up to this point, I've accumulated 73.5. Here now I've accumulated this plus this, 85.2. This plus this, 88.1 I think. This plus this, is that 5.8 Jeff? Yeah, 93.9. And then this plus this, that's 99.7. Yay. You guys see how cumulative frequency works? You just accumulate it as you go.
You can do decimals, right, too, right? That's what it is.
Yeah, you can do decimals, that's fine. I like it. How's everybody feeling so far on this? You guys all right? Some of you guys look worried, but you're like this. I'm okay. All right, so I'm just going to keep going. I'm going to create the histogram, and then I'm going to go back and show you the other way to do this. The only reason people don't like the other way is because it's got inequality symbols in it. People freak out, which really makes me depressed, but that's all right. I'll get past it. I'm going to take our data away because we don't need it anymore. What was the key difference between histogram and bar graphs visually? What was okay here that's not really okay here unless certain things? The space, right? Mind the gap. Yes? was no division. Are you with me on the width was 6? Is that part okay?
No.
The class width was 6.
Yeah.
So if the first number was 17,
Yeah.
when's the next class got to start at 23? It's got to be 6 away, right? But what's kind of sucks about, okay, this is going to show up really quickly, the next kind of level to this. That's got to be 1 down just so that there's a definite place for 23, right? If I put a 23 here also, it's like, where do I put the 23-year-olds? I might double count them then.
You don't.
No. So here's the reality of this. Oh shit. This is why I don't personally enjoy the textbook method myself. Some of you guys might be cool with this. If I were to try to start making a scale based on what I have so far, don't do this. Don't do this. Don't write this down. Do you see how it looks like I'm going to have gaps, right? From 22 to 23. I'm not allowed to have that. So, if some of you guys are like, oh, this already sucks, just wait. I'll show you the other method, and then you can make a choice. Okay. I want to show you this method first, because it is the one that's in the book. So here's the reality. Okay, go with me. Go with me. And you're like, that's all we've been doing. I have a limit to me. Jeff stops existing right there, right? I know this is weird already. Just go with me. So this is my limit. This is the limit of Jeff. But then don't we all have boundaries, right? If you come up and ask me a question and you're right here, I'm like, I just met you the other day, man. What? Can you step off? You're in my boundary. Are you guys with me? You guys with me? Yes, yes, yes. You don't. I don't know what you youngins do now. That's all right. Hey, man, how you doing? I don't think that's still okay. All right. So there's a limit to me. This is the limits of the class. And then there's a boundary to me. This is the boundaries of the class. What would the boundaries of this class be? 22.5 up to. Do you see how these now? See how these now line up?
Sorry. Couldn't it be any number between like 22 and 23? Like
No.
You always have to choose like the halfway point.
To make everything nice and symmetric, we want to pick the halfway point. I like it. What really, really sucks about the textbook method is what if your data is decimal already? Oh, so I'm really hoping most of you pick the other way. But in case anybody wants to do it this way, this is what you have to do. Now when you go to set up the scale, it's going to look like this, 16.5. All I really need to know is this, because how wide is every class? What's the width? 6. So add 6. 22.5, add 6. Add 6. You don't have to say it every time, Jeff. I think you got it. All right. All right, how we doing? Is that all right? So obviously, what's up?
Wait, how did you get those numbers?
Just a half down and a half up.
Oh, but why?
So, because if they graph them the way they are, there will be gaps. And if I see a histogram with gaps, that means there was nobody there. But there are no classes that we had that had nobody in it, right? So my picture better not have gaps, because there's no classes that had nobody in it. It's by definition. Histogram, a gap in a histogram means that's a class that had nobody in it. Did any of our classes have nobody in it? Did any of our classes have nobody in it? They all had people in it, right? So there should be no empty classes. There should be no gaps. They should all be on each other like this.
Well, why can't you use our original classes?
These are our original classes. What do you mean?
So why are you modifying it for like 16.5?
Because if I went 17 to 22 and then started at 23, wouldn't there be a gap from 22 to 23? Okay. So visually, to make a histogram easier to read, we have made it part of the definition. A gap means people that aren't in that region. We don't have any empty classes, right? Now, the other side of this, I want you to understand. Look, I agree with you. That's stupid. right? I hate that shit. But it's in the book, and some people like it, so I want to show you. So here's what the other method will look like. All right, let me say this right now. We haven't finished, obviously, making this histogram, but let me just show you what the other method will look like. The first class for me, if I was going to do this problem, would look like this. 17 less than or equal to x less than 23. See why some people give up. Some people already gave up. He's throwing x in there. Where does 23 go? Second one, because this one's not allowed to equal 23. Where's 22.9 go? If somebody was a real asshole and said, I'm 22.9 years old. Put that shit down. What? That's when you're like 7, you might say, I'm 7 3/4. But where's 22.9 go? Here, right? Less ambiguity here. This is how that was created. Because now, do I need, my limits are my boundary. So this would be the person that has no boundaries. Like, dude, come here, give me tell me about your day. What's going on? I'd be like, dude, that's it. Okay. Right? Okay, like it, maybe. You guys all right? You guys with me a little bit? No, you guys are not with me. You lost me at, hey, glad you guys made it. So this first class could look like this instead. These would not change at all, right? What would this change to? 17, 23, 29, go up by 6. Do you see why I prefer that method there? But people get freaked out about the inequalities. They put the equal sign everywhere. They turn them around. The X freaks them out. So it's up to you. If you're comfortable with this, as you should be after having taken algebra, then you could do it this way. Or you can do it this way for whatever reason. I'm not going to make any assumptions. If you want to do it this way, yeah.
I'm still trying to understand like the book method. So if you were to graph the modified, like the boundaries,
There they are.
how would like the bars look? Because like the classes are still ending at the same way like the next class we get. Like it's still going from 20
Totally. So let's see. What kind of, if I'm going to make a frequency histogram, let me put this over. A frequency histogram. I could make a relative frequency histogram. I'm going to make a frequency histogram. What should my scale be maybe? I have to be able to make it up to what? 25. It's going to be the tallest bar. So maybe I go by 5. 5, 10, 15, 20, 25. Cool. Please, sir God, don't go 5, 15, 30. Your scale has to be consistent. Please. Okay. I like it. Can you? I'm sorry. Can you make your glasses? Oh, I'm sorry. I didn't mean to point you out. I don't know why it was bugging me, but I'm like, anyway. So you're fine. I'll just deal with it. So how tall should this first bar be? There's no question. Either way I do it, how tall is this first bar going to be? 25. What about the next bar? From 22 and a half to 28 and a half? 4.
Oh, okay.
And the next bar? 1. So just kind of estimate that. And then 2 and 2, right?
I get it, because like, in my head I was like, it's the same number, it's starting, but like nobody would be 22 and a half years old.
But all you care about is a class. You don't even know, if I just show you this picture, you have no idea if everybody was here or if they're spread all around or they're all here. All you know is in this range, there's this many people. So it doesn't even matter if anybody is at the end or whatever. Does that make sense? Okay, yes?
So in the end, the two different methods are just to, one place is the eye level, it's just a
Yeah, see, now, I'll tell you this.
They have the same like accuracy.
I'll tell you this. If you do it this way, it's so easy to put the 23s here when they're supposed to go there. One advantage this has is you know to stop counting at 22 and here you start counting at 23. So you do have to, if you want to do it this way, you do have to be a little careful about putting 23 in the right place. That is the only disadvantage to this. Because otherwise you're right, everything else is the same. It's just, I get nice whole numbers I can put there. Yeah. Oh, the only difference, again, so this wouldn't change. These would change. 17, 23, 29, yeah. 35. Because now it goes 17 to 23 instead of 17 to 22, and I don't need a different limit and boundary for that then. That's the power of inequalities, right? They say less than 23, so that could mean 22.9999999. There's no ambiguity. Maybe, yes.
So then, instead of having like these whole numbers, we would just change it as that in there.
I would have, so, okay, maybe that's the real question. I would have this. This is my first class.
Oh,
Yeah, this is my second class.
instead of having 16.
Instead of having 17 to 22, you'd have 17 less equal x less than 23.
Okay.
And then this would still be 25 and 4. Everything else would be the same. It's just the way you identify them would be different. I like it. So here's, you gotta have titles, frequency, and I think this was ages, right? This is ages of us. Ages of us. Sounds like some stupid new CBS show. Yes?
Will the real frequency, like the percentages, how did you add them all up to get 9?
Oh, I just added them all up.
Is that them?
Yeah. Apples. Is that acceptable? Why is it not exactly 100? Because we rounded. No big deal. So don't say that's wrong. You say, okay, they must have rounded. But if you get like 96%, no, rounding don't explain that shit.
I got like 200 something that I did
Dude, we created like double the people. It's crazy.
this. Okay.
All right, maybe. So, now's the time I'm going to shut the hell up. Let me see. Do you guys want to start working on this immediately, or do you want to take a break first? Break first. Okay, I'm with you. So let's come back at 10:50. 10:50. I'm going to start up. 10:50.